Okay, so thank you everyone, and we'll make a start. So we'll talk through the agenda initially, which is we're going to be covering what is GRP, so an overview of the material and what GRP actually is, the different options that are available on the market in terms of luminaires, GRP and non-GRP, and when is GRP not suitable. And then finally, we'll have a look at some design considerations where we'll be comparing boat style versus bespoke. And in both of those instances, we'll compare modern LED fittings. So it'll be boat style LED versus bespoke LED. However, the GRP content is also relevant to a lot of the non-LED boat style fittings. And we'll talk about installation, maintenance, and emergency performance. So first of all, GRP. What is GRP? Glass reinforced polyester or glass reinforced plastic, depending on which definition and where you look it up. Basically, it's a polyester, so plastic material, which is reinforced with a glass fiber. It's commonly known as fiberglass, but it does have subtle differences to what we would term industrial fiberglass. And I'll talk you through the manufacturing process now for GRP. So I'll give you a brief overview of how GRP is actually formed into parts. So firstly, to manufacture the fibers, they use materials such as silica sand, clay, limestone, and other minerals, and they are gradually melted in a furnace until they are liquefied. These fibers are then chopped and formed into mats of material and can then be used in molds or dies to create a range of products. To do this, the molds are first treated with a special chemical mix, and then the first stranded mat layer is fitted into a mold. This is then cured under high pressure and heat. And then this process is continued with another layer of resin and a catalyst added after each new layer. Like before, it's left to cure and then another placed on top. So you make up the shape with layers of pre-made fiber sheets. And typically, GRP will have a lower fiber content compared to what we would know as industrial fiberglass. So that's a little overview of the manufacturing process for GRP. So generally, the design of different luminaires available in the market can be defined in the same way. Firstly, boat-style luminaires, which are made from GRP and are based on traditional fluorescent luminaires, and use a GRP housing which is similar or often exactly the same as the existing fluorescent version. Alternatively, a manufacturer may decide to design a linear luminaire from the ground up, not constrained to using the same design as previously or as an existing fluorescent, and they may choose to use a GRP housing for this. A third option is a bespoke linear using a metal housing. Typically, either stainless steel or aluminium are used for metal housings. And in the presentation today, we're going to look at the strengths and weaknesses of all of these options in a little bit more detail. But first, we're going to focus on the choice of material used for the housing and why GRP may be unsuitable for certain applications. So, of course, GRP does have benefits. It's used widely for many reasons. It's lightweight, durable in the right conditions, and for a manufacturer is very cost effective to mass produce. But when using a typical hazardous area applications, exposure to certain risks may mean that GRP is an unsuitable choice as a linear luminaire. So firstly, chemicals. Certain chemicals and solvents can react with GRP and could potentially cause the housing to become brittle, crack, or even shatter. You may think this risk is restricted to only a few types of applications, but in reality, its effect can be much more widespread. Chemicals or solvents can be present in many cleaning solutions, and any solutions where the luminaires are exposed to oil are also at risk. For this reason, many offshore applications could be at risk, as the fittings can be exposed to things such as drilling mud and cleaning solutions, which can react with the GRP. UV. So prolonged exposure to UV can cause GRP to degrade over time and become brittle. Particularly in hot, sunny countries where the luminaires are installed outside, this presents a big risk of the GRP becoming brittle. It's likely to be a problem during maintenance procedures when the luminaire may need to be opened up or inspected, and any crack in the housing would invalidate the luminaire's EX certification and render the entire fitting as useless. And from our experience, we find that in areas where there is a lot of sun and heat, when upgrades are required, the specifications raised tend to be more for non-GRP fittings, so for aluminium or stainless, than for GRP, with particular mention sometimes to the UV stability requirement. This is because of previous issues they have experienced with things like cracked hinges after opening a luminaire during maintenance and relamping. Now, the overriding reason for this is that when GRP is exposed to chemicals or UV, it is always the parts that are under the highest stress that fail or crack first. So typically this would be the hinges or other fixing points. And finally, what may seem like a mundane or obvious point, GRP will usually be less strong when compared to aluminium or stainless steel in terms of twist and impact. So we all know that data sheets are widely used and can prove very useful. I use them myself all the time, but in reality, they are only a summary of all of the detailed product information. So there's also other parts of a luminaire specification which you should check when comparing luminaires. Firstly, and most importantly, is temperature rating of the luminaire and its expected lifetime. Generally, these stats will be fairly consistent across different styles of fittings and manufacturers. But given that GRP is considered to be a poor conductor of heat, meaning heat is trapped within rather than dissipated through the outer shell, it may be worth checking the spec on temperature ratings, especially for high temperature applications. A metal enclosure, i.e. aluminium or stainless, which is likely to be a better conductor of heat, may be a better option. From my personal experience in Europe, there are many GRP luminaire manufacturers who recognize this and limit the temperature range to a much narrower spread to overcome any potential thermal or performance issues. So typically we would see specs of 0 to +40 for emergency versions and -20 to +40 for standard fittings. An aluminium or a stainless steel fitting should have a temperature range of -50 or all the way up to +50, +55. Sometimes they even go down to -60. The second thing you should look out for is restrictions on the actual certification. So this tends to be an X on the cert. So don't always go off the data sheet alone. you should always check the actual certification for suitability for your specific product. And a common one we see is products have an X on the certification for things like to be used in areas of low mechanical risk only. So that needs to be taken into consideration for the application of the luminaire. And to give you an example, I was looking at a specification only last week, which I downloaded, reviewed the data sheet for a GRP fitting. It was for a Zone 1 offshore application, and it had the statement below as a footnote at the bottom of the data sheet. And it simply said in small letters, for areas with the appearance of oily emulsions, aggressive chemicals, vibration, mechanical stress, we recommend to use the fixtures series XXXX. So the manufacturer actually advised that they should use metal fittings for any of the above reasons, but it was in very small letters. Then the third thing, and often a not very well thought thing, is the recycling. So the third thing to consider is the process of recycling the luminaire at the end of its lifetime. And what is your company's policy on recycling? GRP is very difficult to recycle, whereas materials such as aluminium and stainless are far more renewable, with aluminium being extremely renewable. Aluminium is an infinitely recyclable material, and it takes up to 95% less energy to recycle it than to produce it from primary aluminium. So in effect, it takes 5% of the energy to recycle than it does to create or produce fresh aluminium. This massively limits emissions, including greenhouse gases. And interestingly, today, about 75% of all aluminium produced in the history of the planet, nearly 1 billion tons, is still in use and actively recycled. However, to give a balanced and fair approach, providing the environment is suitable and there are no specific risks using GRP, there isn't anything fundamentally wrong in using a luminaire with a GRP housing. In the correct conditions, it can prove to be a very cost-effective solution. It's therefore important to consider how the luminaire has been designed, or more specifically, how easy it is to install and maintain. These factors are the most valuable to an end user, regardless of the material used for the housing. So it could be GRP, it could be aluminium, it could be stainless. It's still very important to look at the maintenance of the product going forward. So we look at these factors in more detail across the main design approaches of linear luminaires. So in this section, we'll predominantly compare boat style LED luminaires with bespoke LED luminaires. And just to give a recap again on what exactly we mean by a boat style luminaire, the design has been carried forward for decades based on existing fluorescent design, but simply adapted to house modern LEDs. One of the main reasons and driving forces for this is cost. If you look at the image at the top there, that is a huge plastic part with two sides. To typically tool something like that up for mass volume production, you're looking at around £500,000 worth of injection molding and plastic tools. So it's very, very expensive to relaunch a product made of GRP. So they tend to keep the same housing and add LEDs to give an LED version. Also, this is promoted by many manufacturers as a cost-effective way to upgrade from a fluorescent product to an LED product. And indeed, in another webinar and some white papers, we go into a lot more detail on the difference between LED fittings. So like anything in the world, you can have a very good LED fitting or a very bad LED fitting and everything in between. So just because a product is LED doesn't mean that automatically it's a good product. Now, we also call them a boat fitting because they have largely a polycarbonate front cover. All control gear tends to be housed within one large compartment behind the LED module. And because of this carryover of designs from fluorescent to LED, a lot of the design features are not necessary with LEDs. So to give you an example, the large polycarbonate front window is not required with LEDs, as LEDs are a directional light source and need a much smaller aperture to spread the light, whereas a traditional fluorescent tube distributes light in many directions, so a large window aperture was required to channel as much light as possible. Again, another hang-up from converting from old boat fittings to LED boat fittings. So we will compare installation of bespoke and boat fittings. The first thing to mention is that it's easy to replace an existing fluorescent simply because it's a like-for-like housing. You'll be unplugging a fluorescent and plugging an LED version, which is likely to be the same size. They also, manufacturers now tend to offer upgrade kits. They're promoted as an easy and cost-effective solution. But in reality, we find that the cost for the upgrade kit can exceed the cost for a new fitting. So it's a little bit of a false economy. And finally, flex. If the luminaire is not being installed on a completely flat or level surface, or if they haven't been installed perfectly true, even as little as a few degrees offset, there could be some flex in the housing, which may cause issues with water ingress if it causes the gasket to not seal properly. The boat style fitting relies on a gasket sealing all around the front polycarbonate cover. So any twist or any offset in that may cause it to leak. In contrast, a bespoke luminaire manufactured from aluminium or stainless steel should not suffer from these problems, as the housing will be rigid and the gaskets remain perfectly sealed. For a bespoke fitting, some manufacturers, including Raytec, have designed these fittings to be just as easy to retrofit as an existing boat-style fitting, which we will touch on in a little bit more detail in the next slide. And as mentioned, this may sometimes be more cost-effective than replacing with a GRP fitting. So now let's look at the retrofit options. So here we mean taking down an existing fitting and replacing it with a new fitting. Firstly, the dimensions. Your replacement bespoke LED linear should be the same size as your existing GRP traditional linear. If the size is the same, then existing cables won't need to be extended or stretched, meaning there is no need to replace or renew the cables. Secondly, the fixing centers. The luminaire should also have the same fixing centers as the existing GRP housing. Traditionally, manufacturers follow the pattern of 3 M6 and 3 M8 fixing holes. So they can be 3 M8s shielded with 2 M6s either side. If these are located in the same position, have the same threads and depth as a fluorescent, then the same brackets can be used when retrofitting. Utilizing the same brackets on a job could save significant costs and time during the installation. And one point to note is that typically in offshore applications, the central fixing points of a linear are used for a retention bracket, or can be used for a retention bracket, which means provided the two end fixings, so it has its two mounting points, are in place, the central fixing can be fitted with a retention bracket, meaning that the cost and requirement of a protective netting to prevent items dropping is no longer required. And finally, we're going to talk about cable entries. Having the same size and quantity of cable entries will also mean the same glands can be used, providing they comply with the ATEX classification, of course. Traditionally, this will be 2 by M20 entries at each side, or 2 by M25 in Europe typically, or 2 by 3/4 NPT in America, Canada area. And they're each end to allow for through wiring and loop in, loop out setups. When you combine these elements together, you have a replacement LED luminaire which will reduce the time and cost of installation compared to a product which hasn't been designed with these features in mind. So we would like to class that as a true retrofit solution. Now, boat fittings have one large compartment where all components are located. They're designed to be as familiar as possible to the fluorescent fittings, which installers and engineers have been used to for decades. And so the ease of maintenance tends to be restricted by this existing popular design. However, fluorescent tubes no longer need to be replaced, as so more common maintenance procedures with LED fittings is likely to be the driver to the luminaire. A manufacturer of a bespoke luminaire has more flexibility in the design, but not all will use this flexibility. It very much depends on the manufacturer. A little myth that propagates is that LED boat fittings require a micro switch, and we often see this on specifications. In reality, the micro switch only isolates the lamp holders, but the main electronic circuit behind is still live. You must isolate the circuit if you're doing anything other than changing the tubes. And since LED life is over 100,000 hours, you won't be changing the LED driver engines for over 10 years. So micro switches in boat luminaires turn the lights on and off when the housing is opened or closed. And this is a feature that's been carried over from traditional fluorescent fittings. For an LED linear, this therefore results in unnecessary costs and has no value to the end user. And finally, GRP fittings are often colloquially referred to as fish bowls in the field because of the large polycarbonate front and their potential to fill up with water. So boat fittings require a large gasket, as mentioned earlier, typically around 10 foot of gasket to seal the front of the whole luminaire. This 10 feet of gasket is much more susceptible to problems with water ingress and more problematic when it comes to maintenance procedures and ensuring these gaskets are sealed properly. The large polycarbonate is unnecessary, as mentioned earlier, due to the LED light source being a directional light source. And by that we mean a typical linear LED light source will be around 120 or 130 degrees, meaning the light is emitted forwards and sideways, but you only need a much smaller aperture to get the same light spread. What this means in reality is that a bespoke manufactured luminaire, bespoke designed luminaire, can be designed with less polycarbonate on the front a much smaller aperture, which requires a much smaller sealing gasket, typically around half the size, so around 5 foot, which makes the maintenance significantly easier and the risk of IP ingress lower. Here we're going to show a small video to demonstrate how easy it is to replace the PSU on a Raytec Sport and Linear product. And again, this highlights the differences of a bespoke luminaire in comparison to a standard GRP fluorescent luminaire. You'll see there that the power supply is in an end cap that's potted. So it's all EXE certified. Has an integral gasket and retained screws within it. So when the end cap's removed, the screws don't fall off, which is very handy. And the retention clip means it's in place. So we're 2 minutes there to change. Now you may say, well, that's on a production bench, so obviously it's going to be quicker to do, but we can tell you that it is just as quick to do that in the field. Everything is designed with maintenance in mind. So just bear with me for a second. Now we're going to talk about emergency performance. So when emergency variants of your LED linear are required, it's important to look at performance in emergency conditions in more detail. So we've compared the spec on temperature, we've looked at the GRP materials, we've looked at other potential issues on the spec. Now we're going to have a look at the emergency side of a specification. Emergency performance is as simple as chemistry. It is always a trade-off between how much light the luminaire gives off in emergency mode, which is usually a percentage of the normal operating mode light output, and the duration, i.e. how long it will provide light when running off a battery. So as an example, a fitting that offers 10% emergency and has 5,000 lumens as standard will give you, for 90 minutes, it will give you 10%, so 500 lumens for 90 minutes duration. The higher the output, the higher the draw on the battery and the shorter the duration. It comes down to the size of the battery. In this case, size really does matter. And some manufacturers will fit smaller batteries to keep the costs down and improve margins. However, this saving could come at the expense of the end user. So why is that so important? Well, if you specify a fitting with a lower emergency output, for example, 10% power on emergency, compared to a fitting with 25% power on emergency, it means one of two things. More fittings will be required to hit the required light levels, which could add significant cost to the installation, or secondly, that emergency light levels will be insufficient, which could provide a safety risk to those on site. Neither of those options are good. So always check the performance of a luminaire in emergency mode. And to give you an example, a Raytec fitting, a standard intelligent emergency offering, is 25% light output for 3 hours, but they have the option to have anything up to 100% light output if required. So 25% for 3 hours, 50% for 90 minutes, etc. As discussed there, intelligent emergency I mentioned. So modern LED fittings are also emerging now with built-in automation into the testing procedures. These are required as part of the hazardous area inspection procedures. So here we have intelligent emergency systems. The batteries can be cycled automatically to test the emergency functions are operating correctly and communicates the results via an LED indicator. So in this case, it's fairly simple. The green light means everything is good. The orange light means the unit is doing something, either self-testing or in installation mode, and the red light means there's an error. Please review or call the manufacturer. What that means in practicality is on sites where the maintenance guy may have to test the emergency functionality periodically, he would walk around, switch the power off, go back in 90 minutes and check that the luminaires are still operational. In some applications, you can get away with just reviewing the light, and if the fitting is self-diagnosed and is in green mode, you know that the emergency function is fully operational, saving maintenance time. In terms of the testing, these systems incorporate certain characteristics which you can again see on the right-hand side. So we have random testing. This is designed so that if you have multiple fittings, they won't enter testing all at the same time. It's done randomly. Reserve capacity, what that means is that no matter whether the product is at the beginning of a test cycle or the end of a test cycle, you will always have enough power left should an emergency occur to give you the duration you require. And output, there should be no noticeable drop in the level of light during the testing procedures. So coming up to a summary now. It's important to give a very fair and balanced view, and we are not saying that GRP fittings are not suitable for all applications. There are many applications where they are perfectly fit for purpose and indeed do prove to be a cost-effective solution. However, the use of GRP luminaires should be restricted for certain applications, such as those exposed to high levels of UV or where chemicals and solvents are present. While it's important to consider the materials a linear luminaire uses, you should also look at the design of the luminaire. A well-designed luminaire will ensure optimum performance, easy installation, and low running costs can be a bonus, ensuring it is an easy to maintain product. And lastly, always look more closely at the luminaire's backup information. Do not just look at the sales literature. Look at the EX certificate to get a complete picture and ensure the luminaire will be suitable for your particular purpose. So thank you very much for your time today. I really appreciate you taking the time out of your day to do this. I will now answer some of the questions. If you bear with me for a minute or two so that I can load the questions, I'll simply feed them back through the microphone as I am now on the webinar. And if you have any questions, just add them onto the tab at the right-hand side on the questions, and I'll answer them or try to answer them now. Thank you again for your time. Okay, so the first question that we have is, I can understand that GRP reacts with chemicals, and also polycarbonate reacts with chemicals. It's good that the linear window size has been reduced, but will this not still react with chemicals? It's a very good question. In short, the answer is it might. The solution is to use a glass fronted lens. So we are launching a product in the next quarter, or with Corona, potentially the next 2 quarters, that will have a glass front. So it's basically our standard linear product, but supplied with a glass front. So with this, you have a fully aluminium product resistant to chemicals and UV, and a glass front resistant to chemicals and UV. And as a cautionary note, or a word of caution, we have heard feedback in the past that although you may not think chemicals are used in an application, something as simple as someone cleaning a polycarbonate lens with cleaning fluids can cause things to deteriorate and crack over time. So we would always say check the specification carefully. It tends to only be linears fittings that have polycarbonate front covers. Most floodlights, bulkheads, and other products now have glass fronts for that exact reason. Very good question. So another question, which is the same question that was asked at my webinar this morning at 9 o'clock, and probably quite topical. Are our products manufactured in the UK? The answer is yes. Everything is based at our manufacturing centre for excellence in Northumberland. So we have technical, design, sales, marketing, and importantly, the production facility all under one roof, all there to help and work together. And to give an overview of our production facility at the moment, we are still operating. We're operating on a lower staff level than usual, but we're still very much up and running. The majority of the guys in offices are working from home under government advice, and we're making sure that the adequate social distancing is occurring where required on the shop floor, and that all the hygiene measures are in place. So I guess the message is that we're not at 100% capacity, but we're still going and manufacturing product. A question here that says, I have GRP units that seem to be cool, not hot, question mark. Okay, so what I think that means is the surface temperature of the luminaire, and in reality, it's a little bit counterintuitive, but you actually want the luminaire to be hot. With an aluminium fitting or a stainless fitting, they're designed to draw the heat away into the housing and then to evaporate out into the air to aid cooling. What tends to happen with a GRP fitting is that it acts as a thermal barrier, and basically The inside or the internals where you don't want it to be hot are getting hot like an oven, and the externals where you want it to be dissipating the heat are staying cool and insulated. So although it sounds counterintuitive, it's a good thing if the externals of the fitting are actually quite hot to touch. It means that they're doing a good job and they're dissipating the heat. And to give you an example on on our fittings, a linear fitting will have a large extruded profile running down the center, which has a large aluminium LED board. So there you have an aluminium LED board, a large thick aluminium heatsink, which is then in contact with the external aluminium. So it's designed that the heat that comes out of the LEDs draws away through the aluminium and out of the other side. Question here, are GRP fittings suitable for marine applications? So that's a very difficult question to answer because it depends on the fitting and it depends on the application. But in reality, if you want to be safe, you should look for either a stainless or an aluminium fitting for a marine application. And we do have people say, well, stainless steel must be better for marine applications than aluminium. And in raw form, that would probably be true. However, when we manufacture our products with aluminium, we use LM6 marine grade aluminium or 6063 extruded architectural aluminium. It is then pre-treated to guarantee the 1,000-hour salt spray test. It is then, on top of that, polyester powder coated with a DuPont Alester paint, given an extra hard layer, and all external fixings and brackets are marine grade stainless steel. So they're 316 or A4 stainless. And we've been supplying products manufactured in this way for over 15 years, and many of them are still in situ in places like the Middle East, still operating as they should. So a question now. Are intelligent LED linear bespoke luminaires suitable for use in classified areas, e.g. Zone 2, outdoor installation, chemical environment? If yes, are they EX certified for such installation configuration? It's a very good question. So the Raytec Intelligent LED luminaires are Zone 1, Zone 2, and Class 1 Div 2 certified for outdoor installation and for certain environments, and they are EX certified. A question now on case studies. Okay, so once the webinar has been completed, the marketing team will upload the webinar, including the slides and the commentary, onto the website for you to download and use or listen to at a later time. question here. Where would you say GRP linear luminaires are most suitable? Again, that's a very subjective question, but GRP linear luminaires are certainly suitable for most indoor applications where chemicals aren't involved, and certainly suitable for applications outdoor where the temperatures don't get very high or there isn't a lot of UV, and likewise suitable where the temperatures don't get very low. So for certain applications, the GRP fitting would be perfectly suitable. There are other benefits of using an aluminium or a stainless fitting over a GRP fitting, not just that the GRP may degrade, but we won't cover that today. Okay, we've got a question on, again, on some case studies, requesting that we send some case studies. On that one, I'll be in touch afterwards, and if you let me know exactly what information or case studies you would like, I'll see what we have available and send them on or make them available to you. We had a question this morning, so it's not now, but we had one on the 9 o'clock webinar that said along the lines of GRP must be significantly cheaper than stainless or aluminium linears. Is that correct? And like anything in the world, there's a range, so you can get very low cost GRP fittings and very high cost GRP fittings, and likewise with aluminium and stainless. However, on a like for like basis, so comparing similar specification products at a similar quality level, customers are always surprised at how price comparative an aluminium or a stainless fitting is compared to an existing GRP fitting. So the cost to actually change or upgrade to a stainless or an aluminium fitting may not be what you think and may even be a lower cost solution. So I'll give it another minute or two for any more questions to come through. If you have any, please feel free to ask. And if I can't answer now, I will get back to you personally after the webinar to provide you with an answer. I hope you found the session informative. I hope you found it useful, and I hope you take on board some of the tips on how to check specifications and things you should consider when looking at GRP or looking at linears in general. There's a question here on retrofitting, so I'll try to summarize it best I can. Can you use a smaller fitting if you get the same light output. So I guess what is being asked there is that most manufacturers, including Raytec, design the product to be the same size for retrofit reasons. But in reality, LEDs are more powerful, so you can increase the lumen output on a smaller scale. So you could have a 2-foot linear that would give the same lumen output as a 4-foot fluorescent. This would be perfectly suitable, but for retrofitting, we tend to find that customers don't have the slack in the cables to actually do this on a large scale. And so we and other manufacturers offer a middle ground, which is almost a 2-foot fitting in terms of lumen output, but in a 4-foot body. So it gives the same output as a fluorescent, but it's in a 4-foot fitting so that you can retrofit it easily without having to increase the cable lengths. A question here. Have LED luminaires an illumination level better than GRPs in terms of illumination level depreciation during luminaire lifetime? That's a very good question. On the whole, the answer is yes, but it very much depends on the design of the luminaire and how the heat is managed. And so when people ask me, well, when you buy LED products, what do you look for? And I say simply, I look for 2 things. First of all, that there is a quality LED used. And by that, I mean something like Osram or Cree or Philips or Samsung, a brand that people have heard of and has a good quality heritage. But secondly, and more importantly, it's important you can have the best LEDs in the world, but if you're not thermally managing them correctly, then they won't perform and last as long as they should, and the lumen degradation will be higher than it should be. So what I mean by that is that some GRP, particularly the lower cost type products, will have a very high lumen output initially, and they will give you like-for-like performance when you install them. But after 6 months or 12 months, they can drop as low as 50–60% of the initial output. And that's simply down to 2 things. It's down to the LEDs being driven too hard. So they're being pushed as hard as they can to get the most out, the most bang for your buck. And secondly, it's down to poor thermal management. So in terms of components and in terms of LEDs, every 10 degrees that you add to the temperature tends to half the lifetime of the product. So it really is key to keep the LEDs as cool as possible. And at Raytec, and I'm sure other bespoke manufacturers, they design and we design the product around the LEDs. So the whole focus is how can we keep these LEDs as cool as possible for as long as possible. And to give you an idea, you should get comfortably over 100,000 hours, and you should comfortably after 100,000 hours, so after 10 years, you should be seeing between 80 and 90% of the initial lumen output. When you compare that with a fluorescent or another GRP, lower cost product, the lumen output will be significantly lower over time. And in fact, if you look at some specifications for some GRP linears, they have their lifetime as 50,000 hours rather than 100,000 hours for this exact reason. So it's a very important thing to think about lumen degradation over time. It's also important to think about the drive gear or the control gear in a unit. And at Raytec, we make sure that we match our drive electronics with our LED electronics. So by that, I mean you should get 100,000 hours out of the power supply. And to do that, when we manufacture it, we pot it with a silicon resin, which is designed for two things. One, it gives us our EXE certification, so our increased safety certification. But secondly, it gives us good heat dissipation. And by that, we mean it reduces hot spots. So typically a weak point on any electronic circuit will be an electrolytic capacitor, say. And electrolytic capacitors, like other components, as mentioned, every 10 degrees that the temperature rises, it can half the lifetime hours of that product. So by potting it, what you actually do is you raise the average temperature of some components, which is still well within the parameters that they're comfortable operating at. But importantly, you lower the operating temperature of the other critical components, therefore increasing the lifespan of the product. Question here. I can appreciate what you are saying seems correct, but if a GRP fitting fails and is under warranty, can you not just have it replaced anyway by the manufacturer? And there's a short answer to that and a long answer to that. The short answer is yes, you can. The long answer is you probably don't want to, because if a fitting goes down, you have to close the loop and get a permit and have it uninstalled. You then often have to send it back to the manufacturer, and a lot of manufacturers make the customer bear the cost for this. So not only do you have the downtime of the luminaire not working, you have the cost and hassle to send it back. Most occasions, the manufacturers won't take the time to give you a fault report, so they'll simply replace it under warranty, send you a new fitting, which often you have to pay also to get it back out to site, and then you also have to reinstall it. So there is a significant amount of what I would call soft costs and time costs when you replace a fitting under warranty. The Raytec fittings have been designed with maintenance in mind, so that if a power supply should fail, and we're pragmatic enough to say that a power supply is likely to fail at some point in the life of the product, whether that be 10 years down the line or 15 years down the line. So rather than with other products where they are sealed for life and you have to remove them and replace them, we've designed the products in such a way that you can swap out a power supply within minutes and get the site back up and running. And most of our distributors in the regions carry these spares ex-stock, so they would be a fairly quick process to get something up and running again. Okay, I think that's it now with the questions. Again, if anyone has any that they think of afterwards, feel free to drop me a line. You can contact me on LinkedIn, or you can contact me directly if you already have my details. Thank you again for taking the time to listen today. I hope you found it informative. And on a personal note, given what's going on in the world currently, I wish you all good health, stay safe, and most importantly, stay healthy. Thank you very much for your time.